Hi, this is Mrs. Lemoyne, and today we're going to be doing Illustrative Math, Grade 5, Unit 2, Lesson 15, Multiply More Fractions. Our learning goal today is let's multiply mixed numbers. So we're going to start with a number talk. Try to find every value mentally. 6 times 3/8. Well, I can remember that. I can multiply 6 times 3. 6 times 3 is 18, and every whole number is over 1, so 16 eighths. 18 eighths. 18 eighths. Or we could come out here and say how many eighths are in 18, and there are 2. 2 times 8 is 16, and we have some leftovers there. 8 minus 16 would be 2. So we could say that this is 2 whole numbers out of that, and 2/8 left over. 2 and 2/8. Okay, let's see if we can do the next one. 6 times 2 and 3/8. 2 and 3/8. So this one is a little bit different. So remember that I can use that distributive property to say 6 times 2, 6 times 2, and 6 times 3/8 plus 6 times 3/8. Well, I already know what that is, right? Because that was this first one. So that's going to be 2 and 2/8, or I can think of it as 18/8. And this is going to be 12. So I think the answer will be 14 and 2/8. 14 and 2/8. And here's the answer for this one. Okay. Our next one is 7 times 9/10. Well, again, I can say 7 times 9, and I'm going to go, let's get my pen, and then I'm going to make a mark like this, and my work for this one will be down here. So 7 over 1 times 9 over 10. I know that 7 times 9 is 63 over 10. 63 over 10. Or that is going to be the same as 10 goes into 63. 6 times 10 is 60, and I'm going to subtract those and get my leftovers. So that is the same as 6, and what's my leftover? 3, and the denominator always stays the same. So either one of these answers would be correct for that one. All right, let's look at the next one. 7 times 3 and 9/10. Well, again, just like before, I already know that 7 times 9/10 is going to be 6 and 3/10. I can use that distributive property and say 7 times 3 plus 7 times 9/10, which I already know is going to be 21 plus 6 and 3/10. So I can combine those and say 27. 21 plus 6 is 27 and 3/10. There we go. There's a little warm up to help us figure that one out. So I do have an extra question for this one. If someone found 7 times 4 first, what might they do next to find 7 times? What would they do next to find 7 times 9/10? Or 7 times this, 7 times 3 and 9/10. Well, how much more is 4 than 3 and 9/10? It's only 1/10 more, right? So I could find 7 times 4 and then subtract 7 times 1/10, because that would make the 3 and 9/10, because 3 and 9/10 is 1/10 less than 4. So if I did this, I should get the same answer as this. All right, let's move on to our first activity. So our first activity says write numbers from the list in the blanks so that The situations make sense. Each number will be used only one time. Be prepared to explain your thinking. All right. So we have a bunch of numbers up here, and we have to figure out where they belong in the blanks. The area of the rug is 16.5 square feet. So there's my rug. 16.5 is the area of all of it. The length of the rug has to be what? And the width has to be what? So that means I'm going to have to multiply this times this and get 16.5. Well, I need to get close to 16, and I know that 5 times 3 is 15. So I see that here's a number with 5, and here's a number with 5, and then I have the whole number 3, and there are no other numbers with 3. So I'm going to say that one of them is going to be 3. Let's do the width. The width is 3. So will 3 times 5.5 or 3 times 5 3/4 work? So let's do 3 times 5.5. That would be 3 times 5 plus 3 times 1/2. So this would be 15 plus 3 over 2. And from previous lessons, I already know that 3 over 2 is the same as 1.5. So would that be 16.5? Yeah, 16.5. So this is going to be 5.5. So we're using each number only once. So now I'm going to mark off the numbers that I've used because I'm only going to use them once. And I'll erase this one because I haven't used that one yet. Awesome. Okay, so let's look at the next one. We've done number 1. The puzzle is 2.5 feet wide. So again, I'm going to draw a picture. 2.5 feet wide. And it's blank long. I don't know how long it is. It has an area, and I don't know the area. All I know is that it's 2.5 feet wide. That one could be a lot of things, right? So I'm going to skip that one and go to number 3, and hopefully whatever's left over will help me with number 2. So let's do this one. The area of the whiteboard, okay, so I'm going to draw my whiteboard. So the area I know is 23 square feet. So we need to know the length and the width that will get me to 23 square feet. All right, well, I know that 5 times 4 is pretty close to 20, but I need more than that. So what if I did 4 times 5 3/4? Let's try that. So 4 times 5 3/4. So that means I'm going to do 4 times 5 plus 4 times 3 over 4, like that. So this is going to be 20. So what's this going to be? Well, I know that this is over 1. So this is going to equal 12 over 4. And remember that this means division. 4 times 3 is 12. 1 times 4 is 4. So 12 divided by 4 would be 3. Oh, well, there it is. So one length will be 4. And mark that out. And the other length will be 5 3/4. So that really helps me. So now that I know that if the puzzle is 2.5 feet wide and blank feet long, it'll have an area of blank square feet. Well, if I do 5 here, 5 times 2 is 10, and I don't have a 10 up here. So let's put a 2 here, and let's test that. 2 times 2 1/2. So 2 times will equal 2 times 2, and then 2 times 1/2 plus 2 times 1/2. So let's see, it has to equal, in the end, it's going to have to equal 5 because that's the only piece I have left, right? So let's see if that equals. I know that this is 4. 2 times 1 is 2 over 2. Is that a 1? Yeah. So 4 plus this 1 is going to give me 5. So now I have all the answers. 5.5 feet. The width is 3 feet. It is 2 feet wide. It is 5 square feet. It is 4 feet in length, and the width is 5 3/4. And these two could be different, right? And this one too. I could have had these in different spots. Either is correct, isn't it? Right? I could have a 3 here and a 5.5 here. I could have the 4 here and the 5 3/4 here. So then we're going to share our solutions with our partner and explain why you made the choices. And I just explained that as I did it, so I don't think we need to go over that again. All right, let's move on. That was good work. Which numbers did you think made sense for the length of the rug in feet? How did you decide which number to use for the length of the rug? Well, we just went through that, so we'll move on to the next one, equivalent expressions. All right, each diagram represents a way to calculate 4 times 5 2/3. Each expression is equivalent to 4 times 5 2/3. Match the diagrams and expressions to show or explain your reasoning. Choose a favorite diagram and expression to find 4 times 5 2/3. Explain why it is your favorite. All right, so I have to match each one of these diagrams with each one of these, and they are all 5 2/3. Whoops. Did it again, girls. All right, so let us look at that. 4 times 5 plus 4 times 2/3. So I think that one would go with diagram B. I have a 4 here and a 5 and a 2/3. And so I would multiply 4 times 5 and then multiply 4 times 2/3. So I think this one goes here. This is a 4 times a 17. So each one of these would be 17 divided by 3, right? Would give me what this is. So that must be 5 2/3, 5 2/3, and 5 2/3. So is there an equation that looks like that? Well, the only one that I see that looks like that, let's see, diagram or number 4, right? Number 4 might look like that. Does that make sense to you? Because we have 4 times 17, and then we're going to divide that by 3. So I think this one goes with this equation there. All right, let's look at C. C it's divided into thirds. There are 1, 2, 3, 4, 5, and 2/3 here. So which one of these equations would look like that? I think it would have to be this one because I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 thirds. So yeah, this one's going to go with that. So this must go with this, but let's talk about it. 4 times 6, yep, 4 times 6. And then we're going to subtract out that 1/3 that is in white. So that definitely goes with that one. I think my favorite way to do this one would be B. But that's just my favorite because I like doing the whole numbers. 5 is Lemoyne, not 3. Let's get rid of that. 5. And then adding the multiplication times the fraction, 2/3, like that. That to me makes sense to me. But all of these diagrams work. All of them work. All right. So how are these diagrams the same and how are they different? Well, I noticed that here's my 4. Let's get a different color here. This is my 4 times 5. And this is my 4 times, because I still have 4 here, 2/3. And they're both showing the same amount of blue shaded region, right? This is going to be 4 times 6. And then we're going to subtract 4 times the 1/3, right? So they have the same amount of blue shaded in, and they have the same amount of white, but they're labeled differently, right? This one labels the entire rectangle, and it also labels what we're going to subtract out. This one labels only the blue part. So that's how they are the same. That's what I saw as the same, and then the difference. So moving on. Today we used what we learned to find the value of expressions involving multiplication of whole numbers and fractions greater than 1 written as mixed numbers. Tell me everything you know about this expression. So for me, I know that I can represent this as 7 plus 3/5 times 6. So that means I can take that 6 and I can multiply it times the 7, and then I can multiply it times the 3/5, and then I can add those two together, right? So I could do 6 times 7 plus 6 times 3/5, right? So that's what I know. So I know that this to be 42, because I know my math facts. 42 plus 6 times 3 is 18 over 5. Now, in order to add those two, I know I have to make this into a mixed number so I can add it to the whole number. So I'm going to see how many 5s are in 18. I know 5 times 3 is 15 and 3 left over. So that means this is going to be now 42 plus 3 and 3/5. Now I can add the two whole numbers together and add the fraction. And that makes sense to me because when I have this is a division problem, right? 18 divided by 5. How many 5s are in 18? Well, there are 3 whole 5s in 18 with 3 left over. So whenever we see a fraction, we also see division. So that's how I would tell my teacher everything that I knew about that expression. All right. I could also draw an area diagram to be able to solve this, right? I could say this is 6 and this is 7, and then I could split that into 7. 6, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. And we need a little bit more for the 3/5. And then I would have to split each one of these into fifths and color in 3 of those. So I could do a much nicer job of that, but that's how I drew it. So I could draw a picture of it as well. All right, let's move on. All right, here's our cool down. Let's see if we remember what we learned today. So again, I could draw diagrams of these, but I think I'm just going to use my rule of multiplying whole numbers and then multiplying the whole number times the fraction. So that would end up being 12 times 9 plus 12 times 2/3. Now I know my math facts and I know what this is going to be, but I'm going to go ahead and work it out for you guys since some of you do not know your 12 times tables. 9 times 2 is 18. 9 times 1 plus 1 is 10. 108 plus 12 times 2. Remember, if you don't know that, you could do this, but I do know that it's 24. 24 over 3. Again, I'm going to remember that this is a division problem. 24 divided by 3. 24 divided by 3 is 8. So this becomes 108 plus 8, and that's going to equal 116. 116. All right, and I'm going to use the same process for the next one because that is my favorite way to do things. So we're going to do that this way. 3 times 8, we're going to split the 18, go to the whole number, and then multiply it times the fraction. So 18 times 3. I don't know my 18 times table, so I'm going to have to work that out on the side. And over here, I would have 18 over 1 times 5 over 9. All right, so let's do the work over here. 18 times 3. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. 54, right? Did I do that right? Check my work. Yep, 54 plus. Now I don't know what 18 times 5 is either, so I'm going to do that. 18 times, times, let's back that up. There we go. Times 5. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. So this is going to be 90 over 9. 90 over 9. And I do remember that this is a division, 90 divided by 9. All right, so I know that 90 divided by 9 is 10, plus 54 will be 64. 54 plus 10 is 64. All right. Well, that's it for today. And that is it for our unit. Your teacher has 2 optional unit lessons left in the unit, but I'm not going to record those because we don't do those in my classroom. But I will see you in Unit 3. Please like and subscribe if you want me to continue making videos.